This video will focus on how to solve stoichiometric problems when using molarity. So, step one, the difficulty with molarity problems is the fact that there's more than one number. So normally I say you should start every stoichiometric problem by writing down the number that is given. But in this case, there are two numbers given. So the other thing you can look for then is, what is the question asking me to solve for? In this case, the question's asking me to solve for how many milliliters of HCl should I have in the reaction? Meaning this 6 molar, which has to do with HCl, can't be where I start because that has to be where I end. The other thing that's helpful to know is that when it comes to choosing a starting part, you always need to choose to start with a measured number, not a conversion. So our measured numbers are usually gram, mole, or milliliter or liter, so volume. Not molarity, not molar mass, not density, okay, measured numbers. So in this case, the measured number then is this 1.04 grams of zinc, because that's an actual number. And every time I do these problems, I do them the same way, which is multiply and set up my first conversion, knowing that the label I'm starting in becomes the label for the bottom. Okay. With stoichiometry, my goal is to go to the mole, because once I'm in the mole, I can do stoich. Okay, so I am going to go from grams of zinc to moles of zinc, and that relationship is always called the molar mass, and that is a number you can pull from the periodic table. So for every 1 mole, I have 65.38 grams of zinc. Next step then, since now I got myself into moles of zinc, this is my stoich. This is my key that unlocks my door, that allows me to convert into the substance I want to know something about. So I'm converting into hydrochloric acid. And if you come up here and balance your chemical reaction, which you always need, I can see that for every 2 HCl, I need 1 zinc. Okay. Now my goal is to get into volume, milliliters of a solution. And with milliliters, I have 2 choices. I either have a concentration or I have a density. In this case, I have a concentration. So I'm going to set up my next conversion just like I always do. I'm in moles, so that's going to come down. And now because I'm in concentration, I can go from moles to liters given a concentration. So again, 6 big M means that's how many moles I have in 1 liter, which means that's the conversion I can fill in right there. The last step then, which I ran out of some room for, would be to convert from liter into milliliters, and that's what the question's asking me. And it's 1,000 milliliters for every 1 liter. Plugging this into my calculator then, I would type 1.04 divided by 65.38 times 2 divided by 6 times 1,000 to get myself there. And since this number is only 3 sig figs, I'd round my final answer to only 3 sig figs and then label it with the dimension as well as the chemical substance. And that is a, how to do molarity practice for you.